Have you ever wondered how Netflix seems to read your mind and know exactly what movie you will love the next? Or how your weather app can predict rain tomorrow with shocking accuracy? Or why even a game of snakes and ladders follow hidden patterns you never see? It turns out these aren't magic, they are mathematics. Over a century ago, a Russian mathematician, Andrey Markov, discovered a simple idea that can predict the future, model complex systems, and even explain patterns in the world around us. Today, we are going to unlock the secrets of Markov chains, a model so elegant, so powerful that it quietly shapes everything from the internet to AI, finance, and beyond. Get ready to see the world differently, one step at a time. In 1906, Andrey Markov challenged the limits of probability theory. Back then, mathematicians mainly studied independent events, situations where one outcome doesn't affect the next. For example, flipping a fair coin twice. Whether you get heads or tails on the first flip has no impact on the second flip. Similarly, rolling a die multiple times produces independent results. But Markov asks, what if each event depends on the one before it? These are called dependence events. For example, think about the board games like in Snakes and Ladder, whether you are on a square 10 or 25. Your next move depends only on your current square, and the die roll not on the exact path you took to get there. Or imagine the weather. If it rained today, it might be more likely to rain tomorrow. Markov discovered that even with the dependent events, there was a simple pattern. The future depends only on the present, not the full past. This becomes the memoryless property or Markov property. To demonstrate it, he analyzed vowels, showing that patterns in language could be predicted mathematically. And just like that, a small idea grew into a mathematical model that would transform science, technology, and society. Now let's talk about what exactly is Markov chain. At its heart, a Markov chain is like a journey between different states. A state could be anything, the weather, or traffic light, or even whether your phone battery is charged or low. The special rule, memorylessness. The future depends only on the present state, not the entire history. In other words, where you go next depends only on where you are now. For example, a light switch. If it is on, there is some chance it will flip off. If it is off, there is some chance it will flip on. Notice the switch doesn't care how many times you flipped it before. The only thing that matters is its current state. That's the Markov magic, a system that evolves step by step, with each step depending only on the present moment. This elegant idea is the hidden engine behind weather forecast, stock prediction, AI, and so much more. Now let's understand how robots make decisions using Markov chain. Let's take a cleaning robot as an example. Its decision can be modeled using Markov chain, where each possible action is a state. State 1, cleaning the floor. State 2, recharging battery. Or step 3, docked and resting. Now the robot's next move depends only on its current state and battery level, not the entire history of what it's been doing. Suppose engineer measured its behavior and found while cleaning 70% of the time the robots continued cleaning, battery still good. 20% of the time it decides to recharge and 10% of the time it heads back to the dock. While recharging, once recharged, there is an 80% chance it goes back to cleaning, a 20% chance it goes to the dock instead. And while at the dock, the next scheduled task always makes it start cleaning again. 100%. This behavior can be captured in a transition matrix. The transition matrix can be written as P equals to, in the first row, we will be writing 0.7 and 0.2 and 0.1 in a row. And in the second row, we will be writing 0.8, 0.0, 0.2. In the third row, we will be writing 1.0, 0.0 and 0.0 according to the measures we have found. Each row shows that what the robot does next depending only on what it's doing now. This is how Markov chains let robots make smart step-by-step decision without needing to remember every move they have ever made. So this is one of the significant example of how Markov chain can be used in such a futuristic concept or a advanced concept.
Let's model the weather with a simple example. We have two types of days, sunny and rainy. Suppose if today is sunny, there is an 80% chance that tomorrow will also be sunny and 20% chance it will be rainy. Likewise, if today is rainy, there is a 40% chance it will be sunny tomorrow and a 60% chance it will be rainy. We can represent this using a transition matrix like this. Here, the rows represent today's weather and the columns represent tomorrow's weather. Now, suppose today is definitely sunny. We represent this as a state vector like this. To find tomorrow weather probabilities, we multiply the state vector by the transition matrix like this. This tells us that tomorrow there is an 80% chance of sun and a 20% chance of rain. If we repeat this process day after day, the probabilities eventually settle into a stationary distribution, showing the long-term behavior of the weather. Markov chains aren't just abstract math, they have quietly transformed technology, business, and science. Like Google PageRank. Google treats the web as a massive Markov chain. Each web page is a state and each link is a transition. Pages with more links pointing to them have higher probabilities, which is why they rise to the top of your search result. And another one is finance and credit ratings. Banks use Markov chains to model companies' credit ratings. By predicting how ratings move between AAA, BBB, or D, analysts can manage billions of dollars in risks. Language and AI. Early AI language models use Markov chains to generate text. Each word is a state with probabilities derived from real-world text. Today, this principle powers chatbots, translation, and predictive typing. Biology and ecology. Scientists track animal migration using Markov chains. Each location is a state and transitions help predict how population move over time. From the internet to finance, AI to ecology, Markov chains quietly guide many of the systems shaping our world. So, why it matters? Why Markov chains so powerful? Because simplicity breeds strength. By focusing only on the present, Markov chains model complex systems accurately and efficiently. When fed with millions of data points, whether days, clicks, words, they reveal patterns that are invisible to the naked eye. In short, a simple, memoryless idea allows humans to predict, optimize, and transform the world.